Good morning. Today's topic is common ion effect on solubility of ionic salts. Okay. So, common ion effect. Common ion effect usually decreases the solubility of a sparingly soluble salt. Okay. Decreases the solubility of a sparingly soluble salt. Sparingly soluble salt. Okay. Now, let us consider a system in equilibrium. Consider a system in equilibrium. Okay. Consider a system in equilibrium into which we are adding a salt containing a common ion. Adding a salt containing a common ion. What happens? Common ion. Okay. So, if we are adding a salt containing a common ion, the common ion present in the salt increases the concentration of the product side due to dissociation. Okay. Concentration on the product side increases due to the dissociation of the salt which we are added. Okay. Dissociation of the salt. So we know according to Le Chatelier's principle what happens? According to Le Chatelier's principle, the system will try to reduce the concentration on the product side. Okay, reduce the concentration of the product side means the equilibrium will shift in the backward direction. Okay, equilibrium shifts in the backward direction. Okay. Backward direction. So, as a result, what happens? As the backward direction, the equilibrium shifts in the backward direction, more reactants will be obtained. So, more reactants are obtained than the product. Okay? More reactants are obtained than products. Than products. Or we can say there will be more undissociated reactants are present. Okay, due to this precipitation will occur. Okay, precipitation occurs, which means solubility decreases. Okay, this is the reason why if we are adding a common ion to a system which is in equilibrium, the equilibrium will shift in the backward direction, more reactants are obtained than products, precipitation occurs and thus solubility decreases. Okay, we can explain this with the help of suitable examples. Okay, example, consider an example. Add 0.2 molar NaF solution to a saturated solution of CaF2. So, the common ion present is F minus. Common ion is F minus. Okay. So, fluoride ion is the F minus is the common ion present. Now, first consider the reaction without adding NaF. First, NaF is not adding. So, the equilibrium will be CaF2 gives Ca2 plus 2F minus. This is the equilibrium reaction. This is a saturated solution of CaF2. The equilibrium takes place like this and KSP is 5.3 into 10 raised to minus 9. Now, S and 2S. Okay. So, KSP, solubility product will be equal to S into 2S whole square. This is equal to 4S cube. Okay. Now, 5.3 into 10 raised to minus 9 is equal to 4S cube. And S cube will be equal to 5.3 by 4 into 10 raised to minus 9, or S is equal to cube root of this value by 4 into 10 raised to minus 9 whole raised to 1 by 3. Okay, whole raised to 1 by 3. So, the answer will be 1.1 into 10 raised to minus 3. Okay, this let it be S1. So, without adding NaF. Now, next we are adding 0.2 molar NaF. What happens? Adding 0.2 molar NaF solution. So, F minus ion increases. So, solubility here will be S and this will be 0.2 plus 2S. Okay, because we are adding 0.2 molar NaF means F minus ion concentration increases. 0.2 molar increase. Okay, so this will be the value. And we know 0.2 is much greater than 2S. So we can neglect 2S. So this will be equal to S and 0.2. Or KSP will be equal to S into 0.2 whole square. Or this is equal to 0.4S. That is KSP is equal to 0.4S. Or S will be equal to 5.3 into 10 raised to minus 9 by 0.4. Okay, 5.3 into 10 raised to minus 9 by 0.4. 0.2 whole square is 0.04. Okay, 0.04 by 0.04. Okay, so this value will be very less. 1.3 into 10 raised to minus 7. This will be, let it be S2. So, S2 will be 1.3 into 10 raised to minus 7 and S1 will be 1.1 into 10 raised to minus 3. See the difference. So, S1 is much greater than S2. This shows that if we are adding a common ion, if we are adding a solution containing common ion, solubility decreases. Okay. Now, next. So, by adding a salt containing common ion, we can precipitate the sparingly soluble salt. Okay, we can precipitate the sparingly soluble salt, or we can say the solubility decreases by adding a salt containing common ion. This is very helpful in gravimetric estimation. Gravimetric estimation. Example, we are adding HCl gas or passing HCl gas through sodium chloride solution. What happens? Here the common ion is Cl minus. Okay, so we are passing HCl gas through a saturated solution of NaCl. Cl minus ion is the common ion. Okay. So what happens? The Cl minus ion concentration increases and sodium chloride gets precipitated. Okay. Sodium chloride gets precipitated with high purity. So, for the gravimetric estimation of sodium chloride, we can use this method. Okay, by passing HCl gas through saturated solution of NaCl. So, common ion effect is an important application for the complete precipitation of a particular ion as it is a sparingly soluble salt, which is having low value of solubility product. Okay, which is having low value of solubility product. Okay, so a sparingly soluble salt which is having a low value of solubility product, by using this common ion effect, we can easily precipitate with high purity. Okay, now another example, in the case of Ag plus ion. Ag plus ion can be precipitated as AgCl. Another example, as its chloride. Then ferric ion precipitated as its hydroxide. Also barium ion. Barium ion can be precipitated as its sulfates. Okay, as a sulfate. So common ion effect is a very important application in gravimetric analysis. Okay.